Welcome everyone to lesson 7, graphing inequalities in two variable planes. Yes, you heard right, inequalities. So we will be now getting into systems of inequalities, but first we have to look at what it even looks like to graph an inequality. But to get us started, let's remember how to graph. So here is your do now. I want you to graph this system and find the solution. Go ahead. So I used what I knew about slope-intercept form and point-slope form to pull out the key point, and then I used the slope to be able to graph both of these equations to find that the solution, the ordered pair that satisfies both, is 3, 4. So hopefully we feel comfortable with that because we're going to be using that today. So our objective today is review graphing, which is what we sort of just did. And how can we graph an inequality in two variables? What does that look like? So I want to do a quick overview of inequalities. And I want you to notice that we're looking at in one variable plane. And what that means is on a number line versus a two variable plane, which is on a Cartesian graph where we have an x and y coordinate. But remember, two variable plane doesn't mean there are two variables, because we had, for example, x equals 3, which we would graph as a vertical line through x equals 3. So two variables doesn't mean it's in a two variable plane, and one variable doesn't mean it's a one variable plane. It's how we're graphing, on a number line or on a coordinate plane. Now, in a one variable for inequalities, we distinguished open circles and closed circles to show whether we were strictly less than or greater than, or less than or equal, or greater than or equal. Now, in inequalities in two variable, we need another way. And what we end up doing is dotted versus solid lines. And the dotted, like open, is less than or greater, and solid less than or equal or greater than or equal. But we then use an arrow in one variable to show the rest of the solutions. And in an inequality, we use shading. So we're going to see what that's like with an example now. So here's our first example. I suggest that you don't have to follow these steps, but I thought it a useful one that I use. Determine whether you will use a dotted or solid line. Well, since I have less than, I am going to be using a dotted. And it's legitimately just a line that's been dotted. Now we're going to graph the inequality using our knowledge of graphing equations. Well, this is also in slope-intercept form. So my y-intercept is 0, 2. My slope is 3, 2. So therefore, I'm going to graph the y-intercept, use my slope of rising 2, running 3. And you might accidentally make a solid line. Well, if you were using a pencil, well, there's this lovely thing called an eraser, and I can just turn it into a dotted line. Now, again, just like with an open circle, this means things that are on the graph are not solutions. For example, this ordered pair right here, 2, 5, if I was to plug that into the inequality, it wouldn't work because it's on a dotted line. Now, as I was saying, there's then shading. Well, we're either going to be shading this side or we're going to be shading this side. One side will be the solutions and therefore will make the inequality true, while the other side will not. And to do that, we use a test point. Now, I often refer to it as TP, because then I think toilet paper and it makes me laugh. Now we can pick any test point on either side and I will know which side to shade. For example, let's say I pick the ordered pair -3, 0. Well, this is on the orange side, so I'm testing the orange side. Well, okay, 0 is less than 3 over 2 times negative 3 plus 2. 0 is less than negative 9 halves plus 2. 0 is less than, that's a negative 2.5. Well, that's false. Last I checked, 0 is greater. Well, that means every ordered pair on the orange side will be false. And we only want to shade the true. Shading means it will make the inequality true. It's a solution. Well, okay, that means the orange side should not be shaded. So the idea is by testing one point, if it's false, that means shade the other side. If it's true, shade that side. And just to prove it to you, I'll use an ordered pair on the true side, and I'm going to pick one of the easiest ones to test, 0, 0. So 0 is less than 3 halves times 0 plus 2. 0 is less than 2. This is in fact true, and that's why I shaded that side of the inequality. So when we see shading, we should think this is an inequality. So there's our first example. Hopefully you take the moment to add this to your notes. Add key information like the dotted versus solid line. What the shading even represents, it represents our solutions. And solutions are things that make it true. So in this case, make the inequality true. Every single one of those ordered pairs on that green side will make the inequality true. So that's our first example. So let's think about this one now. So we want to graph this. Well, it's greater than or equal. So that means I want a solid line. Well, my y-intercept, because this is slope-intercept form, it's just plus 0. So it's a 0, slope of a negative 2 over 1, solid line. Well, 0, 0 is going to make this true because it's on the line and the line is solid. 1, negative 2 is going to work because it's on the line and the line is solid. So you can't pick a test point that is on the line because we already know whether it's true or false. So again, just to make it visual, we have the orange side or we have the green side, and we can pick one point. You can all pick different points and still figure this out. So I'm going to give you guys a moment to pick a point and think, do I want the orange side shaded or the green side shaded? Well, I'm picking 0, 5. That's this point up here, so it's on the orange side. So I get 5 is greater than or equal to negative 2 times 0. 5 is greater than or equal to 0. This is true. So if you picked shade the orange side, you are correct. The green side should not be shaded. So graphing an inequality has two differences than graphing an equation: solid versus dotted line, and the need to shade. Here is my first practice problem for you. So there's many ways of graphing it. Go ahead. So I haven't fully answered this one. I wanted to walk some through with you. But you see that I knew it was a solid line because we had less than or equal. So that means everything on the line could be a solution. I graphed it by finding the inequalities. So I plugged 0 in for x, 0 for y. I found the intercepts. Now you could have also put it into slope-intercept form. So there it is in slope-intercept form. One thing, make sure if you use that method, If you have to divide by a negative, don't forget to flip the inequality sign, because that's going to make you have a different side that needs to be shaded. All right, now, if possible, the easiest test point is 0, 0. Now, if you do go into slope-intercept form, this is why I wanted to walk you through it. My suggestion, always go back to the original inequality. So 3 times 0 plus 5 times 0 less than or equal to negative 15. That becomes 0 is less than or equal to negative 15. This is a false statement. So wherever 0, 0 is, which is the orange side, is therefore false. I don't want to shade false, I want to shade true. So therefore, this is the graph of my inequality. Make sure if you have any questions on this that you're coming into Google Meet to ask me. Otherwise, here is practice 2. Go ahead. Here is the answer to our second practice problem. Notice I put the y as well, so dotted, because we don't want to be equal on the line. False, so I shade the side 1, 1 is not on. I chose 1, 1 as my test point. You could have chosen 0, 0 again. I just really want you to know that you can pick any ordered pair as long as it's not on the line, because we already know whether those are going to work or not. Those are not going to help me figure out which side to shade. All right. Now, here's example 3. Now, this is an example I'm going to look at, and this is what I was stressing before. There's only one variable, but we can still graph it in a 2-variable plane. Now, I see that I am going to want to have a dotted line. Now, the equation equivalent would be y equals negative 3. That is a line where y is always negative 3. So for example, one ordered pair is 1, negative 3. I don't care what x is as long as y is negative 3. Another ordered pair is 2, negative 3. It's anything negative 3. It means that we have a dotted line that crosses the y-axis at negative 3. Now, this is one of the few that I will not require you to have a test point for. I have it here, and you can easily check it. For example, if I use the ordered pair 3, 4, well, the y is the only thing I could plug in. 4 is greater than negative 3. Well, that's true. But because it is vertical, we know greater is above. So I'm shading up here. So there is my inequality. Now, keep this in mind. The next problems, there's 4 of them, and they're explorations, but I want you to take the time that I ask you to take, and then watch the video afterwards if you get stuck. I am giving you the graph. I want you to write the inequality. There's different approaches to doing it. Some are quicker than others. There are some that have multiple answers. So here's the first one. Take no more than 7 minutes. See if you can write the inequality. That would result in this graph. Use your prior knowledge of writing equations that we've done previously. So for this inequality, we think to ourselves, it is one of those special cases. It's going to be a x because x is what makes the vertical. We just saw the y, which makes the horizontal. So we're thinking to ourselves, okay, it has to do with 5. So our options are this: x is greater than 5, x is less than 5, x is greater than or equal to 5, x is less than or equal to 5. So this one's nice because there's 4 options. We came up with the equation. So that's what we did first. We thought about what it would look like as an equation. In this case, it's x equals 5. And now determine correct inequality, sorry for the sloppiness, sign. Well, right away, it's a dotted line. Okay, not that, not that. I now have a 50-50 chance. Well, pick a value. Well, here's a value, say 3, 0. I need this to be true. I need 3, 0 to be true. Well, the only time, and here I just care about the x value, which is 3. Well, 3 is not greater than 5. 3 is less than 5. There is my inequality that represents the graph. So I'm using a little process of elimination. I'm using a little problem solving, working backwards, using my prior knowledge to get to the final inequality. Here is the next one. See if you can write it. I'll make it bigger so you could see some of the ordered pairs it's going through. No more than 10 minutes. So as I was saying, I need to write that line anyways, because I need the line that represents the barrier. And I'm going to use my prior knowledge. Now, there's different ways you can do this. You could have done slope-intercept form. I can see that there's my y-intercept. And my slope is up 1, 2, 3, 4, 5, 6 over 1. There's the next time it goes. So I could say, okay, y equals 6x minus 2. You could have done point slope form, picked any point that it went through. Those are the only 2 that we can see on the graph that it goes through nicely. Now, I have, again, 4 options. It's going to be less than, greater than, less than equal, greater than or equal. But just like before, I have a dotted line, not that, not that. 50-50 chance. Well, again, I can pick any ordered pair. One from the solution, which is our orange side, or one not from the solution. And so let's say, again, I'm going to pick, say, let's go with, I'm going to pick this, 4, 0. So when I plug 4, 0 in, I want the inequality to be false because it's on the false side. Okay, so let's see, 0, 4. Well, that becomes a 0 is less than 24 minus 2. A 0 is less than 22. Well, that's true. But remember, 4, 0, I want to be false. That means that's not it. Process of elimination, that's it. Well, if you want to feel confident about this, pick any ordered pair on the orange side, and it's going to work. Or pick any on the white side, it's not going to work. Say, for example, let's pick one that we know is going to work. -2, 2. So I get a 2 is greater than 6 times -2 minus 2. 2 is greater than -12 minus 2. 2 is greater than -14. That is true. We wanted it true. There's my inequality. Here's exploration 3. Read the information that is given and make sure that you use it all in writing an inequality that satisfies this. Go ahead. So you could make the graph and you could see it as if it was exploration 1 or 2. Now, Using my ordered pairs, because I have two ordered pairs, I have no slope. I need to get my slope. So I start by getting my slope. Now, there's many different ways of doing this. You don't have to do it exactly the same way. 4 minus -2 all over 6 minus 4. That becomes a 6 over 2. My slope is 3. Now, I have a point and a slope. I'm using point-slope form. Why? Again, it doesn't matter which point you use. I'm going to use the first one. So y plus 2, because it's minus a negative, equals a 3x minus 4. Now, we know it's not actually an equal sign. We also, from this statement right here that tells us the ordered pairs that lie on the actual line are not the solution, my options are either less than or greater than. So I don't have to even bother testing the other two. And we're told 2, 3 is a solution. So I want 2, 3 to work. So let's test the first one. So I'll say 3 is my y value, 2 is my x value. I get a 5 is less than a 3 times -2. 5 is less than -6. Well, that's false. Just to prove it to you, you don't have to. We know it's this one now. But if we say 3 and we plug a 2 in, we get a 5 is greater than a 3 times -2, which is again is 5 is greater than -6, which that is true. So there is my inequality that represents the situation. Again, this is where you might have put it into slope-intercept form. You might have used the other ordered pair. So that way you would have had a y minus 4 is greater than 3x minus 6. That is an inequality that works. As I said, slope-intercept form, that would have been y is greater than 3x minus 14. That would have worked. So there's different situations that would represent this situation that I asked for. Last but not least, here is the last exploration for today. Go ahead. Here are the two possible inequalities that they could be, because we have a solid line. Let's pick something that's in the solution this time. Let's say, why not 0, 0, because that will be easiest. So we want 0, 0 to be true. 0 is greater than or equal to, well, that's just -1. Well, right away, that's true. 0 is greater than -1. So this is my inequality. I don't have to go any further. You might have used point slope form as well. So you'd have a slightly different inequality. If you have any questions, make sure you come to me. Tomorrow, we're going to put this into practice with systems. Hopefully, you're already starting to think about what a system of inequalities would look like and where the solution is for those. Otherwise, have a great rest of your day. Bye, guys.